So debugging means removal of errors from the given code. We have to analyze the code and then we will find errors in those codes, and it is a very common question, as common as pseudocodes themselves. Now you have to keep all those formats in your mind, because that walkthrough of the formats basically help us to spot errors mostly. Okay, read this section of program code that should input 10 positive numbers and then output the smallest number input. So the smallest should be plus 1000, counter is equal to 0, repeat, input a number. If number is less than smallest, then smallest is equal to number. So one error, the other error, counter is equal to counter plus 1, print small. This would go after until 3 errors. And then until counter is less than 10, no, counter should be equal to 10, 4 errors. So you have to understand all this. Small will be minus 1000, and this way, this, if number is less than small, then small is equal to number will be corrected, and then print small will go after the loop, and then until counter is equal to 10, not less than 10, because we have to start with 0, and as soon as it becomes 10, we will get out. Okay. We will start PRM tomorrow. So large should be minus 999. Large should be minus 999. It could be any big number, but on the lower side. Counter is equal to 0 while counter is greater than 30. So that should input 30 positive numbers. Means less than 30, not greater than. Since it is starting from 0, so less than 30. If it starts at 1, then equal to, less than or equal to 30. That would become do. We did not study, but existence of do does not matter. So do is optional. If you write it, fine. If you don't, no issue. Input number. If number is greater than largest, then largest is equal to number. Counter is equal to counter plus 1. And while and print large. There are 4 errors, so we found 4 errors. You have to tell that what are the corrections of these 4 errors. Read this section of program code that should input 50 numbers and then output the average. Total is equal to 0, correct. For counter is equal to 1 to 50, correct. Input number, total is equal to total plus number. Counter is equal to counter plus 1 is not required, as counter is now part of for next loop, and for next loop does it itself. So we do not have to write counter is equal to counter plus 1, because for next does it itself. Then average should go after next. And total is equal to total divided by 10, not counter, so double error. Average is equal to total divided by 10, not counter, because counter, when the loop comes out, whatever the variable in for next loop that we have used will have a value upper bound plus 1. So when the loop finishes for counter is equal to 1 to 50, counter will be 51. So we cannot use counter. We can only use counter when it is while loop or repeat loop for average. Otherwise, it is always the constant. So there are 4 errors. In line 6, there are 2 errors. We have to take line 6. Oh yes, 50. Sorry, Mohammed is very good. This would be 50. All right, go further. Read this section of program code that should input 50 numbers and then output the average of the positive numbers only, not the average of everything. So this would be total with decision. If the number is greater than 0, only then total will be made, otherwise no. So total is equal to 0, positive count is equal to 0, for counter is equal to 1 to 50, input number. If number is greater than 0, then total is equal to total plus number. If number is greater than 0, then counter is equal to counter plus 1. That is correct. So, no, not counter, sorry. Positive counter. Then positive counter is equal to positive counter plus 1. So this counter will be used for only those values which were greater than 50 so that we could find the average. And then average is equal to total divided by positive count is correct. We have to take this outside. So next counter. So how many changes are there? 3. So they say 4. Let's see which one is the 4th one. Positive count. Input number. If number is greater than 0, then total is equal to total plus number. If number is greater than 0, then positive count. Okay, and then average. So 1, 2, 3. Average is equal to average. And then print number. Okay. This is in another line. So this is not print number. This is print average. This is the 4th error. We have to print average. Now, if you do remember, I taught you about divisions type. So this is quotient and it is found using div function. This is remainder and it is found using mod function. So there are 3 types of divisions. One is absolute, 16 divided by 3. The answer would be 5.333. The other one would be 16 div 3 and that would be 5. The next one would be 16 mod 3, that would be 1. So there are 3 types of. Yes, Umama, output should be average. So it says that this this pseudocode inputs an integer. The predefined function div gives the value of the division. Y is equal to 10 div 3 gives 3, and the predefined function mod gives the value of remainder y is equal to 10 mod 3, that is 1. So input x input x, what do they say? Let's see. Trace the table for input 37. Trace the table for input value 37. So x t1 t2 output. So x t1 t2 output. So input x. What is x now? 37. While x is greater than 15, yes, it is greater than 50. T1 is equal to x divided by 16. 5 remainder. So T1 becomes, this is div. T1 is div. This is T1 and this is mod. This is T2. So T1 is 2, T2 is 5. So now case T2 of, T2 is 5. So T2 is neither 10, nor 11, nor 12, nor 13, nor 14, nor 15. So otherwise output T2. So output will be 5. End case. X is equal to T1. So now X is no more 37. It has become 2. And while. And while sends you back to while. And while says that while X is greater than 15. So X is just 2. It is no more greater than 15. So we will come out of first while loop and then it is case X of. So X is now 2. It is not 10, not 11, not 12, 13, 14, 15. Otherwise output X. So second output would be 2. All right, so that's about it. Now it says that trace table for 191. So you do it yourself, okay? State the purpose of the pseudocode in part A. Now this is very important. Part A basically divides the value until the value is greater than 15. Once it ends, it outputs T1, which is the mod or the quotient, and output T2. Sorry. It divides the number until the number is greater than 15 and it divides the number by 16. All right. And it keeps doing it and finding T1 and T2. T1 is the quotient and T2 is the mod. As soon as the number becomes less than 15, it gives out the quotient as output and remainder as output. Read this section of program code that input positive numbers, discard any negative numbers, and then output the average. An input of 0 ends the process. An input of 0 ends the process. So read this section of program code that input positive numbers. As soon as you enter negative number, the loop is discarded. That is a condition-based loop. And then output the average. Input of 0 ends the process. Total is equal to 0. Counter is equal to 100. This is error-based system, so it has to be 0. Repeat and then another repeat. So this repeat goes until here, this repeat goes until there. So inside loop works completely for every outside loop. So now what is this? This is validation. If you enter any number which is less than 0, this loop should work. So you have to make it greater than 0, so that as soon as someone enters a positive number, this loop is finished. Otherwise, it will keep asking for the number, because by virtue this question requires you to have only positive numbers. So this is a validation. All right. So this is basically limit check. So you have to have every number greater than 0. As soon as the number is greater than 0, you get out of the loop. If it is not, then you remain in the loop and it will keep asking you. That is validation. Total is equal to total plus 1 is wrong. Total has to be total. So it is being added to the input. Counter is equal to counter plus 1. Counter is 1. Total is added to the variable. Counter is added to 1. We already have 4 errors. So average is equal to total divided by counter. This is absolutely correct, because counter is started from 0 and it is being added. And as soon as counter, when we get out, the counter would be actually 1 ahead of the actual number of inputs. Okay. Now, the last thing that we have to understand is that this loop will be finished. The outside loop will be finished when the number is 0. If we use this with greater than 0, then we will never be able to enter 0. And they say that the loop, the process should be finished with 0. So you have to allow 0 to be input as well. When you allow 0 to be input, total would have no effect, but counter will be increased automatically by 1. Okay. So the last input will be 0. That will increase the counter. That will not affect the total. So that is why when we divide for average, the counter should be reduced by 1, and then we will find the average. Okay, so there are 4 errors. Input 10 numbers, check whether each number is within a specified range, total the numbers within the range and outside the range. Okay, so inside the range, outside the range, everything needs to be initialized to 0 as far as it is the largest, and smallest means extreme values. Input a number for count is equal to 1 to 10. This is correct. Input a number, it is correct. If number is greater than 10 and number is less than 20, then in range is equal to in range plus 1. This is absolutely correct. Okay. And else outrange is equal to outrange plus 1. This has to be outrange plus 1. Count is equal to count plus 1. In for next, we don't need count is equal to count plus 1. Next s and next x. So next not x, but basically this is what with for count. So this should be next count. So how many errors do we have? 3 here, 1 there, total 4. Decide with reason whether the number 10 and 20 are within or outside the range. They are outside the range. Why outside the range? Because the check says that number is greater than 10 and number is less than 20. So had that been greater than and equal to, then 10 and 20 will be, and less than or equal to, then 10 and 20 will be inclusive. Since it is greater than 10 means it is from 11 to 19 and less than 20. So they are not part of it. So they are 10 is outside the range and 20 is outside the range, because the check is greater than 10 and the other check is less than 20. Had that been greater than or equal to, or less than or equal to, only then. सर किसी एक सवाल में एरर की एक्सप्लेनेशन लिखवाना है, तो बेटा वही एक्सप्लेनेशन एरर देखें, एरर आपको एक्सप्लेनेशन नहीं मांग रहे, वो आपसे मांग रहे हैं फॉर एग्जांपल ये है, अब वो कह रहे हैं एरर बताओ, एरर फोर एरर क्या होगा, आप बताएंगे कि नेक्स्ट एक्स, एक्सप्लेनेशन नहीं है, वो बेसिकली करेक्शन है, नेक्स्ट एक्स, आप बोलेंगे करेक्शन जो है वो है नेक्स्ट काउंट, दैट इज हाउ इट इज। आपको सिर्फ बताना ये एरर है और ये एक्सप्लेनेशन तो यहाँ पे मांग रहे हैं। Since you have used what? Greater than 10. Since you have used what? Less than 20. That is why it is outside range. 10 and 20, they are outside range. Had that been 5, 5 जो था वो within range होता, क्योंकि ये सॉरी 5 नहीं 15, क्योंकि ये 10 से ग्रेटर था और 20 से लेस था, ये इनसाइड द रेंज होगा। This section of code asks for 50 numbers to be entered. The total and average of the numbers are calculated. So again, variables should be initialized as 0. Print when prompted, enter 50 numbers one at a time. Good. This is correct now. This is correct. This is a prompt. Repeat. Print, enter a number. This is a prompt as well. Good. Input a number. Good. Total is equal to total plus number. I told you in computer science, assignment is from right to left, not from left to right. So from mathematics point of view, total plus number is equal to total is correct, but from our point of view, it has to be total is equal to total plus number. Number is equal to number plus 1. No, it should be counter is equal to counter plus 1. Until counter is equal to 50, that is correct, because we have started at 0. As soon as it becomes 50, we have to get out. Average is equal to number, no, total, not multiply but divide. Total divided by counter. Print the average of the number that you entered is then average. So how many errors are there? 4. Error 1, line number and correction. See, Hamis, error 1, you have to tell that error 1 is counter is equal to 50. Line number is 2. What is correction? Counter is equal to 0. That is how you have to basically tell them. An algorithm has been written in pseudocode to input 100 numbers and print out the sum. In this case, sum is just the total. So count is equal to 0, sum is equal to 0, repeat input number, sum is equal to sum plus number, count is equal to count plus 1 until count is equal to 100, and then we have to, as soon as count becomes 100, we get out. Find the error in the pseudocode and suggest a correction. There is just one error I told you about, and print sum. Rewrite the algorithm using a more suitable loop structure, and that is what? For next. For count is equal to 1 to 100, input number, sum is equal to sum plus number. Sum is being used instead of total. Next, and output sum, and then count is equal to 0 and sum is equal to 0. This section of program code asks for 80 numbers between 100 and 1000 to be printed, greater than 100 and less than 1000, and to be entered. It checks that the number are in correct range and stores them in an array. It counts how many of the numbers are larger than 500, counting with decision, and then output the result when the program is finished. There are 4 errors. Count is equal to 0 is correct. For index is equal to 1 to 80. This is done. Input, enter a number between 100 and 1000. While number is equal to 99 and number is equal to 1001. No. This is basically while number is greater than 99, since they wanted to have this, see, 100 and 1000 inclusive as well. That is why they have used 99 and 1001. So number should be greater than 99. So at least the number that you can enter is 100. And similarly, number is less than 1001. So at most the number that you can enter would be 1000. So this is a way of inclusion. They might have written greater than or equal to 100 and less than or equal to 1000. Instead, they have written greater than 99 and less than 1001. Input, this is incorrect. Please try again. Okay, this is validation. Okay, so it has to be true. So this needs to be revised. If it is validation, while the number is less than 100, and instead of and we have to have or, and number is greater than 1000. So this loop will work if the number is less than 100 or number entered is greater than 1000. This is a validation. This is validation, and this is range check. This is validation, okay? While number is less than 100 or greater than 1000, this loop will work. And then inside the loop, you have to have this number entered again. Okay? So here we go. This is basically entered. This is incorrect. Please try again. Number and while and so it will go on. So now number 80 is equal to number. No. Here comes the index. We have to save all these numbers inside the array. The name of the array is num. So let's say this is the array. The name of the array is num. This is 1, 2, 3, 4, and it goes on for how many times? 80 times. So index will be 1 at the first. As soon as the number is entered, that number will be assigned to array's index. So when index will be 1, it will be this area. When index will be 2, then it will be this area. And then when index is 3, then this will be this area. So this is the next error. If number is greater than 500, then count is equal to count plus 1. This is correct. Until index is equal to 80. No, this is for next loop, so we will be using next index. Because this was for index, this is next index. Then print index. No, we have to print what? The count. And the count was, if the number is greater than 500, then count is equal to count plus 1. So it says that how many of the numbers are larger than 500, and then output the result when the program is finished. So this is print count. These are 4 errors. So print count and print numbers were larger. So whatever the count, first the count will be appearing on the screen, and then a line that says that numbers are, let's say if the count was 10, then 10 numbers were larger than 500. Okay, so you need to be very much attentive. Whenever there is a validation, there would be a little confusion. You have to, line number 7. Line number 7 is basically index. It says that you have to have 80 numbers and put them in an array. Store them in an array. So you take number of whatever the loop index is, at that particular index we will store that number. So this is again div and mod, but this time the application is different. So if it is 16 divided by 3, sorry, 3, then this is, so this 5 would be, now they say 16 comma 3, and if it is div, it is 5, and if it is mod, then it is 1. That is how they are doing it now. So let's solve this. This is again with the help of arrays. For count is equal to 1 to 7. For count is equal to 1 to 7. Input number, digit count is equal to number. So the first, this is tracing now, tracing. So the first number entered is 5. So digit count, count will be what? In first loop, count will be 1. So this would be digit 1. So digit 1 will be number. So which number is entered? 5. Next count will become 2. So this will become digit 2. The next number is 7. So this would go to digit 7, digit 2. Then count will be 3. So digit 3. The number that is entered would go to 3. That is 0. Then count is equal to 4. Number is 1. So it will go digit 4. Then count is equal to 5. Number entered is 2. And it will go to digit 5. Then count will be 6. Number entered is 3. It will go to digit 6. Then count will be 7. Number entered is 4. Then digit 7 will become 4. Then the loop ends. We get out. Now it says that sum digit 1, which is 5, plus digit 7, digit 3 is 0. So digit 1 is 5, digit 3 is 0. Then say digit 5 is 2. Then digit 7 is 4. So 5 and 4, 9 and 2, 11. So the output of this particular bracket will be 11. Now multiply by 3. So 11 multiplied by 3 becomes 33. So the output of this whole phenomenon here is 33. Plus digit 2. Digit 2 is now 7. Plus digit 4, which is 1. Plus digit 6, which is 3. So that is 11. So 33 plus 11. So output of this is 11. So 33 plus 11, the answer is 44. 44. So that 44 is assigned to what? Sum. So sum is 44. Then it says that if mod sum 10, sum is 44, we divided by 10, so 10 fours are 40. So if mod of sum with 10 is not equal to 0, yes, it is not equal to 0, then digit 8 is equal to sum div 10. This is sum div 10, multiply 10 plus 10 minus sum. So digit 8 is equal to 6. So if mod of sum 10 is not equal to 0, mod was what? 4. Then we get inside it. We first find this div of it, which is 4, then multiply 4 by 10. That is basically 40 plus 10 becomes 50, then minus sum, that was 44. So 6 is saved. So this is kind of that, what do we call it? Oh, validation, check digit. So this is check digit. So output GTIN. So you have to write GTIN, and then for count is equal to 1 to 8, output digit count. Output digit count. So which digit is this? 5, 5, 7, 0, 1, 2, 3, 4, and 6. So this is your answer. GTIN dash 8. Sorry, this is not completed. Let me write it properly. So this you have to first write GTIN dash 8. GTIN dash 8, and then digit 1, digit 2, digit 3, digit 4, digit 5, digit 6, digits 7 and 8. So 5, 7, 0, 1, 2, 3, 4, 6. That is your answer. Try the next itself by yourself, okay? Now it says in part B, explain the difference between, explain how would you change the algorithm to input 8 digits, 7 digits, and a check digit, and output the check digit entered is correct or not. You have to explain. So you will say that we will input all of the 8 digits, and we will take first digit and second digit and third digit and fourth digit and fifth digit and sixth digit and 7 digit. And then what we will do, we will find the total of them. Then we will divide that by 10, find the div, multiply it by 10, and add 10 to it, and then subtract the addition of those 7 digits sum from the result, and then we will have our digit. Then we will compare the digit with the 8th digit. GTIN is nothing. This is basically a check digit. Check digit is what? This is basically a digit which is either substituted before a number or after the number. When we enter the number to the computer, What computer does take that digit out, and rest of the numbers will be utilized for the whole mathematical operation, which is not fixed. That operation might be anything. As it is described in this particular algorithm, we will say that according to this algorithm, whatever the operation that had happened, we will complete that operation with the 7th digit, and we will find our own check digit, and we will compare that check digit with the 8th digit. Okay, I have sent this file to you all, and if you want to practice this question, I'm leaving it with my marking, and then you try it at home by yourself. Now, this pseudocode algorithm input 2 non-zero numbers and a sign. Sign is either plus or minus. And then performs the calculation shown by the sign. It might be division, it might be multiplication. An input of 0 for the first number terminates the process. Input number 1, number 2, sign. While number 1 is not equal to 0, if sign is plus, then answer is equal to number 1 plus number 2, and if sign is minus, then answer is equal to number 1 minus number 2, and if sign is multiply, same. If sign is not equal to division and multiplication and minus and plus, then answer is equal to 0. If answer is not equal to 0, then output the answer, and if. And then it takes the number again. I told you in format 2, we enter, we take input before while and before and while. Okay, so that is how it works. Let's see what they ask for. They say we have got 5, 7 plus. So 5, 7 plus. So let's start with it. Number 1, number 2, sign. Number 1, number 2, sign, and then answer and output. So first one is 5, 7 plus. So number 1 is 5, number 2 is 7, the sign is plus. Since sign is not a number, we have to put it in double or single quotations. If sign is equal to plus, then answer is equal to number 1 plus number 2. If sign is not, this would not apply. If answer is not equal to 0, then output is 12. Then input number 1, number 2, and sign. So other one is 6, 2 minus. 6, 2 minus. This is done, this is done. 6, 2 minus. So if sign is equal to minus, then number 1 minus number 2. So answer is 4 and output is 4. Third one is 4, 3 multiply. So 4, 3 multiply. So if sign is multiply, then number 1 into number 2, answer. So answer is 12. Then we have what? 7, 8, question mark. 7, 8, and question mark. So it says that if sign is neither of plus, minus, multiply, and divide, then answer is equal to 0. If answer is not equal to 0, then output the answer. Since our answer is 0, there is no output. Then next, 0, 0 divide. 0, 0 divide. So while number is not equal to 0, so as soon as it is 0, nothing will happen anymore. So you will leave all these parts. So that's your answer. Tracing. These are four programming concepts. Let's talk about it so that we could finish it. Library routine. First, we have to understand what is a function. We have just seen two functions, div and mod. There are other functions we discussed like integer, log. What are these functions? These functions are pre-written small units of programs which are independent. Means they don't have to do anything with the program as well. Whenever you call them and you give them value, they perform an operation and result is given back. That is function when the result is given back. So functions are those subroutines. Subroutines are sub part of the whole program routine. Subroutine. Those subroutines which are independent of the main program, and when they are called with the values, they return values, are called functions. Functions return values. So a subroutine that does not have to, sorry, this is wrong. A subroutine that is available for immediate use, a subroutine that always returns a value. Okay. A subroutine that always returns a value is function. A subroutine that does not have to return the value is procedure. So it takes some input. For example, if there is a subroutine that prints, so you give a value that prints, that's it. It is not returning a value like div, mod, integer, log. It just takes input and consumes it. Finish, done. Then what is the library routine? Library routine is basically a collection of procedures and functions which are ready to be available, which are available and ready to be used. So a collection of procedures and functions which is readily available. Whenever you call them, they are there. That's called library routine. A standard subroutine that is available for immediate use. And it is a collection of all those. Structure diagram. Structure diagram is when we describe a program like this. So a program is divided into these subroutines, and these subroutine might also be divided into other parts. So this particular diagram is called a structure diagram. An overview of the program or subroutines. So this is a structure diagram. Sometimes we call it top-down approach, modular diagram. That's about it. So what is a procedure? A subpart of the program which does not return a value. What is a function? A subroutine of the program or subpart of the program that always returns a value. What is a library routine? Is a collection of procedure and functions, and they are readily available as soon as you call them. They are there for your service. And structure diagram is basically a graphical view of the connections between all the subroutines and how a program is made, what are the parts of the program. And if there are parts of the program that are called subroutines, and if there are further subroutines to that part as well. That is how it is. Okay. This is a section of program code. Total is equal to 100.00. Print, enter the height of each member of your class at a time when prompted. For count is equal to 1 to 30. Print, enter a height in meters. Input height. Total is equal to total plus height. Print, total divided by 30. Count is equal to count plus 1. We don't need it. And next count. And this would be 0. 1, 2, and 3. There are 3 errors. This algorithm shows a number to be entered it then calculates and output the next number in the mathematical series. So this fib stands for, this is my perception, you don't have to do anything with it, Fibonacci numbers or Fibonacci CI. Fibonacci numbers. So it says that fib is equal to 1, previous 2 is equal to 0, previous 1 is equal to 1, input a number. So input a number, that is number 7. If number is equal to 0, no, we go to end if, while number is greater than 2. Now a loop will work. Fibonacci is equal to previous 2 plus previous 1. Previous 2 plus previous 1 will be 1. Previous 2 is equal to previous 1, 1. And previous 1 is equal to Fibonacci 1. Number is equal to number minus 1, 6. And y, number is greater than 2. Yes, it is 6. You go back. Fibonacci is equal to previous 2 plus previous 1, 2. Previous 2 is equal to previous 1, 1. Previous 1 is equal to Fibonacci 2. Number is equal to number minus 1, 5. And while takes you back, it checks if the number is greater than 2. Yes, it is greater than 2, it is 5. Fibonacci is equal to previous 1 plus previous 2, 3. Previous 2 is equal to previous 1. Previous 1 is equal to Fibonacci. Number is equal to number minus 1, 4. Goes back, checks if the number is greater than 2. Yes, number is 4. So Fibonacci is equal to previous 2 plus previous 1, 5. Previous 2 is equal to previous 1, 3. Previous 1 is equal to Fibonacci 5. Number is equal to number minus 1, 3. It goes back, it checks if number is greater than 2. Yes, it is greater than 2. So it gets in. Fibonacci is equal to previous 2 plus previous 1. So 5 plus 3, 8. Previous 2 is equal to previous 1, 5. Previous 1 is equal to Fibonacci 8. Number is equal to number minus 1, 2. It goes back, checks if number is greater than 2. No, it is now equal to 2. So loop will break up. And then it says that output Fibonacci, so that is 8. This is the last Fibonacci. Okay. I'm leaving it to you. This is an easy part. This is an easy one. Do it yourself. The following pseudocode uses a nested if statements. If response is equal to 1, then x is equal to x plus y. Else if response is equal to 2, then x is equal to x minus y. Else if response is equal to 3, then x is equal to x multiply y. If its response is equal to 4, then x is divided by y. Output no responses, and if. They might be asking for case and end case. Name the type of the statement demonstrated by the use of if then else. This is nested if, nested selection, or nested if. Rewrite the pseudocode using case. Rewrite the pseudocode using case. So how we will do it? It is all built around response. So when there is just one variable which is being evaluated, Hafsa, I mentioned that they have actually discussed Fibonacci numbers, but they have not mentioned it. So all we have to do is to go with the algorithm and take a note of it, do the tracing, and that's it. By the name of the variable fib, F-I-B, I found out that it is Fibonacci numbers. Because subroutines are the programs, modern programs are not written as one single unit, rather they are written in different parts. Different people make different parts and then they put it together. So those different parts are called what? Subroutines. There are two types of subroutines, functions and procedures. Functions are those subroutines which return a value. Like mod returns a value, div returns a value, integer returns a value, log returns a value. And there are subroutines which do not return a value. Procedures are subroutines which do not return a value. And functions are subroutines which do return a value. Combinedly placed at one place, they are called library routines. Now, since this is built around response, we will be like case of response. So if it is 1, if it is 2, if it is 3, if it is 4, so if it is 1, then x is equal to x plus y. If it is 2, then x is equal to x minus y. If it is 3, then x is equal to x multiply y. If it is 4, then x is equal to x divided y. Otherwise, the word for else in case is otherwise. Otherwise, output no response. Like this. And then and case. ठीक हो गया? So you see how many ifs and else are there. So this case of response is rather a smaller selection method when there are multiple outputs expected against one single variable. In this case, it is response. Solve it yourself. This is easy. Oh, since this is the last question, let's solve it together. And this is, I believe, binary search. What happens in binary search? Let's first understand it. Now, don't please get bothered about binary search. I'm just telling you so that you have an idea that what we are going to do. This is not the part of your syllabus. This is just an algorithm which is actually given to you. This is binary search algorithm without, like with Fibonacci numbers, without explaining Fibonacci numbers, they have given an algorithm that was actually finding Fibonacci series numbers. This is an algorithm which is trying to find a value inside an array, all right, but with the help of a technique called binary search. So what basically happens, let's say you have got an array of so many places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, the values are 2, 3, 5, 6, 8, 10, 12, 12, 13, 14, 16, 18, and 20. And let's say this is an array, name is whatever, let's say A array, AA. This is 0, 1, 2, 3. Do not call it 0, 1, 2, 3, so you would have trouble understanding it. Let's call it 1, 2, 3, 4. This is index 5, 6, 7, 8, 9, 10, 11, and 12. Now what basically happens that you want to look for a number. So let's say the number that you want to look for is equal to 13. What system will do? System will try to find the center of this. System will try to find the center of this array. So what will be the center? Center will exactly between 6 and 7. 1, 2, 3, 4, 5, 6 values above, 1, 2, 3, 4, 5, 6 values down. So center plus 1 will be taken. So let's say this is lower bound, this is upper bound. So center or middle is equal to lower bound plus upper bound, and we will div it, div of lower bound plus upper bound, comma 2. So what is lower bound? 1. What is upper bound? 12. What it is? 13. 13 divided by 2, 6. 6 are 12, remainder is 1. So this is div. So there we go, 6. But middle is now, according to this formula, is basically here between 6 and 7. So 6 is considered as the middle. Now the value at 6 is checked. It is 10. It is 10. So if it is compared with number, 10 is less than number. So all of the values before this 6 are now scrapped. They are ignored. And the lower bound is now 7. Then again the whole process would go on. This time lower bound is 7. Upper bound is 12. This is now 19. This is divided by 2. 9s are 18. Now your div gives you a middle which is 9. So you go to 9. Now check what is the value. That is 14. 14 is greater than 13. So all the values after the 14 are now ignored. First, this was ignored. Now this part is ignored. Upper bound is now 9. Or maybe you can make it 8 because the value was already checked. Upper bound is now 8. So the values are updated. So lower bound plus upper bound divided by 2. This is now middle. You check 7. This is 12. So this is not the value. Now the lower bound is moved to basically 8. Now both upper bound and lower bound are 8. So this is 16. Now you divide 16 by 2. This is 8. So this is now your new middle. So if you check the value, you find it. So had this been serial search, we will reach 13 in 8 searches. Since it was binary search, we reached at it in 4 searches. So basically binary search help us to reach a number or search a number in less turns. So what basically happens, you have got an array, you input the number that you need to search in the array, you take that number, apply this formula, lower bound plus upper bound, divide by 2, find the quotient, and that quotient is your middle. You go to the middle, you see if the value is there that you are looking for. If it is not, then you have to compare if the value that we are looking for is higher than the value at this current location or not. If it is higher, we ignore the upper part and we bring the lower bound down. If it is lower, then we ignore the lower part and we bring the upper bound up, and we keep changing upper bound, lower bound, upper bound, lower bound, and finally we reach out to that value. So let's see how this algorithm actually works. So this is called binary search. If you want to describe the function being performed by this algorithm. So this is binary search. So let's see what they are doing. First, last, user input. First, last, user input. Middle, found output. Middle, found, and out. So first is 0, last is 16, found is false, input user in. So input data is 10. While first is less than or equal to last. So first is less than last and found is equal to false. Both are true. Middle is equal to first plus last 16, diff 2, 8. So 8 is middle. If my data middle means, let's say what is at 8. At 8 it's 14. It is not 10. If my data middle 8 is using no, else में आते हैं. If 10 is less than my data middle, yes, 10 is less than 14. Then last is equal to middle minus 1. So last is equal to middle minus 1. So last has become now 7. So this is no more 16. First is lower bound, last is upper bound. Then and if, and while. Now let's check. If first is less than last, yes, and found is equal to false, yes. We go in and now we have to find the new middle. First plus last 7 divided by 2, 3, and that is this 3. The middle is now 3. If data at the middle is equal to user input, no, this is 6. User input is at 5, by the way. No. If my data middle, which is 6, is equal to this, no. Else में आ जाते हैं. If 10 is less than 6, no. Else में आ जाते हैं. First is equal to middle plus 1. So now first will be updated and it is now 4. So lower bound has been increased and now it has become 4. So we go to the end, we come back to while. If first is less than or equal to middle, yes. Oh, sorry, less than or equal to last, yes. And found is equal to false, yes. Now find out middle. 4 plus 7, 11, diff 2, 5. Now middle is 5. So let's see what is at 5. At 5 we have what we are looking for, 10. So it says that if my data middle, which is 10, is equal to user input, yes, then make found true. So found is now true. And we won't go inside else part because we don't have to. And then end while. Now, while again first is less than or equal to last, yes. And found is equal to false, no. Found is now true. So this loop will break out, and this do is optional, I told you. We get out, and what we have to output found. So output will be true. That's it. So this is binary search. And what is the purpose of it? The purpose of it is to find a middle point, go to that middle point, look for the value. If the value is there, well and good. If it is not, then you have to compare the value at that point with the value that is required to be searched. If that point's value is less than the value which is required to be searched, the upper part of the array will then be ignored and the lower bound will be brought forward. Okay. अब आपके पॉइंट ऑफ व्यू से इसका क्वेश्चन का आंसर क्या होगा? डिस्क्राइब द फंक्शन बीइंग परफॉर्म्ड बाय द एल्गोरिथम. You don't know anything about binary search. It is not part of your syllabus. So all you would do, all you will write, all you will say is this algorithm is trying to find an input value in an array by applying a certain technique. That's it. This is just for 2 marks. And if you do remember, then say that this is a binary search technique. By applying binary search technique, since it is not part of the syllabus, you don't have to write about it. All you have to tell is that this algorithm is trying to find the input value in an array using a method. That's it. Okay. So we discussed, and if there were any additional parts we discussed as well. Let's get back. So we have actually completed tracing and debugging. Everything now is finished at this part. All pseudocodes in all conditions are done, and computer language is not required. But if you do remember, there was just one thing that I asked, that you have to learn the declaration, and I did teach you declaration of the array in a language. All right. This is done as well. Now the flow charts. Now the flow charts. Let's take a break, and then we will go on for further flowcharts and all. Let's take a break of 15 minutes. So this is 7. I'll get back at 7:15. Thank you. I'll restart this webinar. Okay, I'm going to stop this webinar and I'll get back in 15 minutes.